I'm Judy Zeline, and I'm glad to have you back on the Milker Government Channel. Aquatic invasive species are hitchhikers, and their spread is not inevitable. Those of us who do business or spend time on or around the water can unintentionally help aquatic invasive species spread. Learning about how these organisms live, grow, and reproduce can help stop them from spreading. Reducing the spread of these silent invaders is vitally important. Prevention saves money and jobs and protects lakes and rivers. We all have a responsibility to care for and manage our nation's waters and to help educate others about the importance of preventing this spread. Here to explain the impact these invaders have on us right here in Lake Erie is James Gracio, PhD. He's a Great Lakes biologist with the DEP Office of the Great Lakes, right?
Right.
Okay. You guys, your titles, they're tongue twisters.
Right, we try to get them on one business card.
Oh my goodness. Jim, thank you so much for joining us in this program. When I first think about aquatic invasive species, I really don't feel it impacts me, but after talking with you, we're going to show our viewers just how much it impacts us right here in our own backyard.
Right, they really do.
Yeah, first off, let's get a little bit about your background.
Okay.
How did you get on board with this, and how long have you been with the DEP?
Sure, well, I've been with the DEP since 1992, and we have a number of water pollution biologists that work for the agency, and we're responsible for assessing streams and lakes, testing fish to see if they're safe to eat, and those are things that I still do. But we began to specialize in issues related to Lake Erie over time, and they decided it was appropriate to create this Great Lakes biology position, and I was fortunate enough to get that. And really my heart is in Lake Erie. It's a fascinating place to work. I think it's a great opportunity to focus resources where we really need them here in Erie, Pennsylvania.
Okay, now aquatic invasive species, let's start referring to it because they like to use acronyms, AIS. Okay? So what is the DEP's role in AIS?
Okay, so first let me just kind of explain, I think, what AIS are. So aquatic invasive species, these are non-native plants, animals, bacteria, little tiny invertebrates in some cases that are not native to Pennsylvania or even to North America. And the problem with aquatic invasive species is that they can impact the environment, they can impact the ecology, they can eat or outcompete some of our native species that we care about, especially with the importance of fishing to the region.
Right.
But they can also impact the economy. It costs an awful lot to deal with these species once they're introduced. And in some cases, for example, in the case of West Nile virus, they can even cause public health impacts. Okay.
So the DEP got involved in this?
Right. So our agency's role is primarily to provide scientific support, to monitor for these species, and we play a role in permitting if treatment is required. We also serve as a member of the State Invasive Species Council, along with the Pennsylvania Fish and Boat Commission, our sister agency. We work closely with them, with the Department of Conservation and Natural Resources, and a number of non-government organizations as well.
Okay. Now, me, John Q. Public. Really, what's my role in aquatic invasive species?
Well, first of all, your role is to care about them. And I can imagine people saying, well, I'm not a biologist and I really don't like to eat fish, or I'm not a fisherman, so why should I care? And the reason you should care is because it affects everything that happens in an infested waterway and the region. And so, for example, think about the impacts of zebra mussels, these little tiny invaders. These guys, they don't look like much. They're about the size of your thumbnail. Here they are growing on one of our native clams. We call them unionid mussels.
All right.
So maybe who cares about the clam? Who cares about, the fact that these zebra mussels in fact killed this clam because the clam was no longer able to open its valves to feed and to respire?
Okay.
Well, what you should care about is this same ability to cling to the clam allows these zebra mussels to cling to the intake to your boat motor. It allows these little zebra mussels and quagga mussels, their cousin, to cling to water intakes, for example, the municipal water intakes that we rely on here in Erie, Pennsylvania. And it costs a lot of money to clean those things off. It costs a lot of money to fix your boat motor should it become clogged by these zebra mussels. The Erie Waterworks probably spends upwards of $50,000 a year just on the chemicals needed to keep these things off the intake lines. And of course, that cost gets passed on to us, the users of the resource.
Of course it does.
Yeah.
We're going to get in depth, on some of the actual specimens, but briefly, can you give me what are like 4 of the specimens that we're going to be talking about?
Oh my gosh, unfortunately, there are so many that we could choose from. Believe it or not, over 185 non-indigenous, that is non-native, not organisms that didn't evolve here in the Great Lakes are now found in the Great Lakes Basin. I think it's important. It's important to clarify. Most of these organisms are not harmful. In fact, some of them are quite beneficial. Let's think about a terrestrial invasive species that's going to be familiar to a lot of Pennsylvanians: the ring-necked pheasant. That's a game bird that's stalked actively by the Pennsylvania Game Commission, and we enjoy hunting it. If that bird is no longer stalked, it goes away. Those populations will not maintain in the Pennsylvania environment. The same thing, you may be surprised to hear this. Steelhead trout, that's a very popular sport fish that
yes,
probably a $10, $11 million industry per year when you think about the associated tourism benefits. That, in fact, is a non-native species. That's a Pacific salmon. So that's a species that's not native to the Great Lakes. It's intentionally introduced, and it provides an economic benefit. It's stocked, though. Those populations are artificially maintained. If the Pennsylvania Fish and Boat Commission should ever decide to stop stocking that species, it would not persist in this environment. So it doesn't have those invasive qualities. A subset of those 185 non-native species, however, are highly detrimental, and I brought just a few of those to talk about today.
Okay, but the bottom line is all non-native species, they're not all harmful.
Absolutely not, absolutely not. But the ones that are harmful can have some very surprising impacts.
So I'm learning. And when people say, well, who cares? I'm going to tell you something, viewers, you got to care about this because this really does affect us.
Right.
You explained to me, and I found this very interesting, you call it your laws of ecology.
Oh, yeah.
So, and the first law of ecology is that everything is connected to everything. You don't think about that.
Well, this gets to the question of when we look at, for example, guys like our buddy like the big head carp here.
Okay.
Well, people can catch these on hook and line, and fishermen often ask me, they say, well, why wouldn't I want another fish to catch? Well, here's the problem. You need to think about 2 ecological laws, right? And that first law is that everything is connected to everything else, right? So think about it like this, Judy. Think about the environment, the ecosystem as an intertwined net. You can't tug on one end without moving every other node in that net, okay? And often those impacts, those cascading effects are very, very unpredictable. And sadly, we have a lot of examples of that. So the first thing is realize that when a non-native organism comes in, it's going to affect the environment in ways that we often can't predict, and sometimes in very surprising, detrimental ways.
Okay, tell me about your favorite thing. There's no free lunch.
Okay, right.
What do you mean by that?
Right. So this gets into the second law of ecology, and again, it answers the question: why should I care? Who cares? What's the big deal about a new fish?
Right. That's a nice big fish.
It's a nice big fish, and you know what? These are impressive organisms. The problem is, like Granddad used to say, everything needs to be in its place, and these are no longer in their place. These fish, these mollusks, and this is a type of fish as well that we'll get to, they evolved with certain competitors in a certain ecosystem with various stresses and pressures, and typically these are not problematic in their home range. So these aren't necessarily bad guys, but they can do bad things when they're introduced into the non-native range.
All right, okay. Now, there's so many different impacts, environmental impacts. What are some of the environmental impacts that we see?
Oh gosh, let's
Don't you love that I'm saying, okay, in 3 seconds, tell me everything that you know.
The sad thing is, I think, where do I start? Let me use the zebra mussel as an example, because this is, if you are from Erie, Pennsylvania, or northwestern Pennsylvania, you're used to this. You don't necessarily give it much thought. I mean, these don't look very impressive, right? They're the size of your thumbnail. Personally, I'm not a native clam, so they're not going to grow on me and kill me. But here's what they do. one single zebra mussel the size of your thumbnail,
Okay.
and by zebra mussel we'll say zebra mussel, quagga mussels, this same kind of genus.
All right.
These guys are unlike anything that North America has ever seen before. Our native mussels, they have a completely different life history, a completely different strategy for life than do these non-native invaders. Let's start with the fact that these non-native invaders act like barnacles. They can cling with these sticky byssal threads. They can cling to any hard object, not just living organisms like the clam, but again, water intakes, boat motors, vegetation, your dock, anything firm enough for them to grow on. And if they don't have that, they'll just start growing on each other. So they're a biofouling organism. This is an organism that can cause, problems by clogging up infrastructure.
All right.
All right, so there's a big impact right there. But let's dig a little bit deeper. One single zebra mussel can filter about 1 liter, a little over a quart of water per day, okay? So again, that's a lot of water going through the body of one little mussel, and that's how they feed, that's how they make their living. So multiply one of these by, I don't know, a quadrillion, and you have a sense for how many living biological filters are now present in Lake Erie. So what they do is they can actually change the chemistry, they can change the biological and physical habitat of the entire lake. These guys, they're an example of a species that was introduced from a discharge of ballast water from a freighter. So these freighters carry ballast water to keep them stable as they're transiting the ocean. And then when they take on cargo, they need to discharge that ballast water. Well, any living organisms, fish, mollusks like this, the resting eggs of some species that you cannot see with your naked eye, they would be discharged into the water as well. And I lost my train of thought.
How do they get here in Lake Erie?
Right. So the way they arrived in Lake Erie was from a discharge of ballast water from an ocean-going freighter.
That's how it all started.
That's how it all started. And then, of course, unlike an oil spill, unlike a chemical that you would dump into the water, these guys are living organisms, and a hallmark of life is the ability to reproduce. They have DNA.
So they're, yeah.
You don't clean these guys up.
And
they
then they're
continue
gone.
to proliferate, right? And their populations, when they were at their peak in the early 1990s, they were introduced probably in the early to mid 1980s. They were first detected in 1988, but by then they'd been here for a couple of years. But at their peak in the early 90s, they shut down water intakes. A famous example is the water intake to Monroe, Michigan on Lake Erie. They shut the water intake down for 3 days. Can you imagine in today's environment losing your ability to have public water for a few days?
Imagine.
And this is a big risk out west now as they've hopped the continental divide into the western states where water is such a scarce and precious resource.
Wow.
So that threat is still there. And they were able to filter the western basin, the smallest, most western basin of the 3 that occur in Lake Erie. They filtered all of the water out of that basin through their bodies in about 3 days. Wow. Imagine that. That's a heck of a biological vacuum cleaner.
This really does have an impact on the environment. Yeah. Okay, now let's talk about hitting our pocketbooks.
Okay.
Now, there's also economic impacts.
Oh, there are huge economic impacts. You may not care so much about the fishes and the ecology, but you should care about the impact to your wallet from these species. And these costs are not always obvious.
Right.
So I think I mentioned already that the Erie Waterworks, they spend about $50,000 to treat zebra mussels. But think about the cost of sending divers out to clear intakes. Think about the cost of these organisms washing up on the beach and, because of their sharp shells, cutting the feet of bathers that are using the beach. That might discourage people from visiting the beach when these are washing up on the shore.
And we're a recreational area,
Oh
too.
my gosh, think
Boating
about
and fishing.
Tourism is a huge part of Erie's economy. So this could dissuade people from visiting, and certainly as they spread inland, you do see those effects. You see beach closures. Here is a surprising effect of these organisms that you might not think. Because they are filter feeders, easier for me to say.
See?
What they do is they ingest food and any associated contaminants that are in the water right around them as they live on the bottom of the lake. So there's a chemical called PCBs, polychlorinated biphenyls. These were chemicals that were used very broadly in transformers and in hydraulic oils up into the 1970s where they were banned. So these are no longer produced. However, they persist in the environment. What these guys do is they concentrate this chemical in their body tissue.
Okay.
So concentrations of these PCBs, which are a known harmful chemical, can be 300,000 times the concentration in a zebra mussel that they are in the surrounding water. Okay, again, who cares about PCBs and zebra mussels? Well, maybe not. But think about the little fish, and an example would be the round goby, also a ballast water hitchhiker, and that was introduced into the Lake St. Clair in about 1991. Well, it turns out that the round goby is from the same area as the zebra mussels, this black Caspian Azov Sea region, which is an important donor region for a lot of these species that are now in the Great Lakes. Well, guess what? The round goby eats the zebra mussel. A large round goby, 80% of its diet may be small zebra mussels. What happens is the concentration of chemicals in the zebra mussels is magnified up the food chain. So 300,000 times the concentration in the surrounding water in the zebra mussels, well, maybe multiply that by 10 or so. That's the concentration of the chemical now in the small fish that eats the mussel, like the round goby. Again, these small fish like the round gobies, while they are very destructive in their own right, where they can eat the eggs and the immature, the fry of species like smallmouth bass love to eat the round gobies. So what happens is the concentration of these chemicals further magnifies up the food chain. So by the time you get to the smallmouth bass, the concentration of PCBs may be 100 times what they are in the zebra mussel. And of course, now these are fish that we're interested in catching and eating ourselves. So there are these brand new pathways for the biomagnification, increase of these chemicals from the sediment to these little clams, to the small fish, to the big fish. And that wasn't happening before the invasion of things like zebra mussels and gobies.
Wow. Well, you know what, Jim? I'd like to talk about a little bit more about the species, some specifics that these little buddies that you brought.
Sure.
Okay. This we know they're zebra mussels, and we've really realized the impact that they have. What is that guy in that tall, big jar?
Right. So we'll go back in time now. So here's a species that was introduced from ballast water.
All right.
And this guy really put invasive species, aquatic invasive species, on the map. And what this is a sea lamprey. And this is a parasitic, primitive, jawless fish, not native to the Great Lakes, certainly not native to Lake Erie and the Upper Lakes. But what happened was, as humans started building canals in the 1800s for commerce, they allowed not only boats and barges to pass through, but they allowed fishes to swim. And this is a type of a fish. And the deal with this particular fish is that it's a parasite. What it does is it attaches to a large fish host with its sucker-like mouth.
All right.
And it has a rasping...
It has a...
It's a face only a mother could love.
Oh, my goodness gracious.
But wait, there's more. It has a rasping tongue, so after it attaches to the side of the host fish, it will actually drill a hole in the side of the fish, and it will drink the fluids, the bodily fluids from that fish, often killing the host. Now, we have some native lamprey species. Some are parasites. They're very, very small. They don't kill their host. These guys often kill the host fish. In fact, these guys invaded through the Welland Canal. If you recall, the Welland Canal, that's the canal that bypassed Niagara Falls, which of course was a great barrier to anything that might be trying to swim upstream. Well, the Welland Canal bypassed the Niagara Falls, and it was enlarged several times over its history. And the last expansion occurred in about 1919. 2 years later, sea lampreys were found in Lake Erie. Okay.
Oh my gosh.
They proliferated, they spread throughout the Great Lakes, and by the mid-1940s, we saw a collapse of important commercial fisheries, fishes like whitefish, cisco, a top predator called the lake trout, which is ecologically important. Those fish were essentially eliminated. Now, not all the blame goes with the sea lamprey. A lot of the blame goes with us for overfishing.
But still, this guy was part of the blame.
Those two factors interacted and the fisheries collapsed. So that is a huge economic and commercial impact. In fact, this particular species, Petromyzon marinus, is responsible for the creation of the Great Lakes Fishery Commission, and a large part of their mission today is to control the sea lampreys. Guess what? These are still in the Great Lakes. These are still in Lake Erie.
Oh my gosh.
We don't often see them. Don't worry, they're not going to attach to you when you go swimming, but they are going to attach to our native fishes, and they often kill them.
Okay. That last jar down there, they look like big fat worms down there. What are those guys?
Right. So part of the interesting story with the sea lamprey is that they have an amazing life history. They have an amazing way that they make a living.
Is this the same thing as this?
This is the same thing as this.
Are these babies?
These are babies. These worm-like creatures, some of them don't even have eyes developed yet. These are the larval form, and they look quite different than the adult. The larvae, or we call them amicetes, if you're a biologist, the amicetes live in tributary streams that flow into the Great Lakes. And they burrow into the sediment, they just filter organic material out, they're completely harmless at that stage, and they're forage for native fish. But what happens is they'll live for 4 to 6 years, they keep growing, they'll transform into this parasitic adult phase, then they swim downstream into the lake, and then they wreak havoc for about a year and a half, right, until they return to spawn.
Oh, okay.
And fortunately, that element of their life history is something that the Great Lakes Fishery Commission can take advantage of by treating the tributary streams with a lampricide that specifically targets lamprey species.
Okay. Who's this guy, big guy over here?
Okay.
That we have mounted.
All right. So.
What's his story?
Well, his story is that we don't think he's here in the Great Lakes yet. There is some evidence. There's been some genetic evidence. That a few individuals are present, but we don't think they're here yet. But here's the story. This is a big head carp. I'm just going to slide these aside so you can take a good look at this guy here. So I'm sorry I couldn't bring in a good specimen, but here's a small big head carp. These guys are like biological vacuum cleaners. They're commonly called Asian carp. Asian carp's a very loose term, though. We have a sister species called the silver carp, and that's the species that's well known for jumping out of the water.
They're the jumping fish.
The jumping
flying fish.
The flying fish, the jumping fish, or the silver carp. Same genus, very closely related.
Does he do this?
What's that?
Does he go jumping?
No, he's much too big to do that.
Okay.
But what he does, he can grow to be 5 feet and 100 pounds. That would be a very large adult bighead carp. But what these guys do is they swim around with their mouths open, and they're like biological vacuum cleaners. And they don't eat other fish, but what they do is they eat the microscopic animals and plants that are the base of the food chain for all of our native fish. You think about a walleye, you think about a largemouth bass, and you think about, well, these are fish eaters, and they are as adults, but as immatures, when they hatch from the egg and they first start feeding, they all rely on this microscopic plankton to live. So this gets back to that second law of ecology idea, right? The pie is only so big. There's only so much food to go around.
Okay.
So imagine, you order a pizza, and your kids come home and they bring some friends with them. Well, you were looking forward to a few slices of pizza. Well, now you're probably not going to get any because the kids and their friends are going to have the pizza. Okay.
And that's that's the principle of what you're looking at.
Same thing is happening here. These guys are going to take a big slice of the pie because the pie is only so big. The pizza's not getting any bigger when your friends come over. But what's going to happen is these guys are going to consume that for themselves. So that could really lead to the collapse of the fishery. In fact, recent studies estimate that if these fish were to invade and become established in the Great Lakes, and Lake Erie, by the way, is by far the most susceptible of the Great Lakes because it's preferred habitat for these fish, they may become 1/3 of the biomass. If you weigh all the fish that are living in Lake Erie, 1/3 may be these guys. Again, why should I care? Well, do you care about the natural heritage that we have as Pennsylvanians, right? Do we care about our walleye, and do we care about largemouth bass and yellow perch and other species that could be directly impacted from competition with these big, voracious biological vacuum cleaners?
Jim, we're getting to the end here. We only have a couple of minutes, but how can, briefly, how can we help, prevent some of this from spreading? How is we as an individual, maybe a boater or an angler, how can you help?
Great. Well, the important thing is that these invasions are not inevitable.
Okay.
So in Pennsylvania, we do really rely on boaters, anglers, and waterway users to help us prevent the continued spread of these species. And a few simple precautions will go a long way to preventing some of the impacts that we talked about today. We ask boaters in particular, clean, drain, and dry your boat before you leave any waterway. Take a moment to pull the drain plug, to drain your bilge, drain your live well, drain your bait bucket to make sure these organisms aren't being spread. And by the way, just because you can't see a fish swimming in your bait bucket, it doesn't mean that there aren't harmful organisms there.
Right.
An example, also plants, little fragments of aquatic plants on your trailer, they can actually be viable. They can be transported to a new lake, a new river, and they can start reproducing. A single fragment can produce a new colony. And I've been talking about fish and clams today, but some plants like hydrilla is an example. The near perfect weed can be extremely harmful, and they can ruin your property values as they invade and smother your lake.
Where can people get more information if for some reason we didn't touch base on something, or more information about these species?
Sure. Well, of course, they can contact state government agencies like DEP and the Pennsylvania Fish and Boat Commission. Also, the Sea Grant Network in the Great Lakes is a fantastic resource. They have a lot of great fact sheets and watch cards and everything you need to know about the worst species, their biology, what you can do specifically to prevent the spread of those organisms.
Jim, thank you so much for joining us on this program and letting our viewers know how these species can impact us right here in our own backyard in Lake Erie. I appreciate you coming on, letting us know about this really interesting stuff, really scary looking stuff too, I got to tell you.
My pleasure, G. Thank you so much for your time.
It was a pleasure.
Appreciate it.
Viewers, again, if you have any questions, you can give them a call. You want to check out their website, get more information on it. Yeah, really, there's a lot to learn. But again, thank you for tuning into the Milker Government Channel again. Until next time, have a wonderful day.
You're watching the Mill Creek Government Channel, powered by WQLN Public Media.